Good morning. I'm very happy to be here and presenting. The focus is really simple. We're talking about tactile sensors. And obviously, we want to know why tactile sensing in robotics is important. Of course, if you want to make robots to do manipulation with end effectors, and your end effectors will be in touch with objects, and the interaction will involve forces, and perhaps finger body deformations or object deformations. So it would be crazy if you would not make use of force information in building your robotic manipulation models and in making the robots to be capable like human beings are able to do. So in the attempt of building a generalist robotic manipulation model, especially within the existing framework, such as VOA or VTLA, incorporating the modality of tactile information is essentially vital. Although we do hear from many other people, many other sessions, that they would be able to say that video would solve all the robotic manipulation problems. If you are an engineer, if you're ever trained as a true robotist, of course, that's not going to be true. So how tactile matters in getting generalist robotics models? Essentially, there are multiple challenges for us to do. First of all, is how do we get the tactile information? And in other words, what would be the right tactile sensors embedded into robotic hands, among their fingers, among their skins, and whether or not we are able to obtain the essential force, especially dense force information, for us to make use of the tactile information. The other part is related to building the generalist robotic manipulation models. And there we all know we need data. So we may need real robot data, or we need data that coming from human operators when we perform robotic manipulation, which is a trend now that ecocentric data are recognized to be very, very essential and for fine-tuning to get your generalist robotic manipulation model work. At the very top is how do you build these models. If you have heard talks and in this big conference and others, we are essentially making use of AI, a deep neural network, and there are frameworks such as VOA, now VTLA, which I will elaborate a little bit, perhaps word models, for us to get closer to generate a truly generalist robotic manipulation model. For me, for many of us, it's going to be a long process, but there is a great deal of effort. We have seen them in this conference. So let me start with sensors. So we have tactile sensors. We also have the haptic devices. For tactile sensors, especially if you want to have very dense force information, such as what a human fingertip is able to sense, we need some kind of a mechanism that allow us to build a tactile sensor to be able to embed it within a space of a fingertip, but also able to sense very large areas of contact with dense distributions of normal forces as well as tangential forces, pressure, as well as sense of a contact and sense of a slippage, even including identification materials as well as such as temperatures. So our company, Daimon Robotics, has been building one of the types, which is based on vision, based on camera. The idea is very simple. You have a deformed surface on your fingertip. So there is an inner side of that fingertip surface. That surface will be deformed along with your fingertip deformation. So we will put a camera inside your fingertip, watching a layer of marker embedded on the inner surface. And from optical flow tracking, we're able to generate tangential and normal forces in a very dense manner. So with this, you could do the signal processing to identify the key elements of contact information, such as potential of a slippage, stuck, other type of models which I listed over here. So making this sensor to be practical, reliable, economically viable, and very effective, that has been first 2 or 3 years of our development of our company. And now we do have a set of sensors on the market, commercially available. Some of them are displayed outside in the demo area. We are able to actually compare and benchmark our sensors with varieties of others. And we think that our sensors do fulfill the purpose of generating dense force measurement of elastic fingertips. So we think that is a good step. What we are doing now is to make use of the tactile information for building generalist robotic manipulation model, especially for multi-fingered hands to do dexterous manipulation. So with tactile information, as you have also heard from many other speakers, and now you have the modality that allows you to interact with the environment, to explore especially the object that you are interacting with, to identify the material properties, to be able to get to know, in conjunction with visual information, understand what you are doing and how the object is being manipulated, whether or not you are actually performing your task. So that is one of the major research area which you probably have heard among many other talks. So there is a great deal of alignment, contact information with visual information, and make use of them for exploration and also for model building. The other part of that is that once you have tactile information, in addition to visual or other language as well, so you have multi-modalities in your model. So language, vision, tactile information, and make use of them to build a generalist model. That is something that many people are doing. When you go to AI conferences or our robotics conference, you hear a lot of different architectures, different frameworks, and everybody is claiming they're doing some success. Of course, we are doing that as well. But to me personally, we are still a long way to go to get there. But all these efforts are very essential. We are trying out, we are gradually recognizing the importance of variety of modalities of data and figure out where to get them and how to incorporate them into building a right model. So at our company, with my research group, we do have a framework we call UniTac VLA. Everybody has their names, and we do have a paper, but it's not going to be presented here. Oh, the conference is almost over. We will be hopefully at an AI conference, NERPS, robot learning conference. The last piece, which I want to tell you about, is that tactile information is part of the data for training your model. So data becomes extremely valuable and extremely important. And this is the big deal in generalist robotics. And what data you need, how do you get this data, and where to put the data in the pipeline, pre-training or fine-tuning, or last part of the reinforcement learning. So we do have our own process for generating and processing data, and we do have also data centers where we try to build and operate. So for us, we are interested in egocentric data, where we would like to have our tactile sensors built into data collection devices, and then human operator would be able to make use of the devices to generate the data either in a data factory or in the wild while you are doing your homework, meaning cleaning your dishes, and the data will be generated. So just about 3 weeks ago, we have sent out a data set in the public domain and with very large set of tactile visual data information in conjunction with some of our collaborators at the research institutions. So our aim is to build a set of data set in the public domain that cover a large range of manipulation types and also with high quality to help our community to grow and to develop. If I can show this video, that basically carries the essential information that egocentric type of data is very critical, and we do have devices, UMI type, and which is displayed outside. And if you are interested in joining us in this effort, we would welcome you. And in this way, we hope that we'll be able to help to build a good ecosystem eventually to see the robots with the hand, with the dexter manipulation capabilities as good as humans, if not better. Thank you.